Bismillah ar-Rahman ar-Rahim. Hi dear third year medical students, we will talk today about data presentation. What we mean by data presentation, how to present the information taken through our study from a sample group. So the presentation, there are four types. Either it is mathematical presentation or it is tabular presentation. Here we have a table and present our information or data on this table, and graphical presentation as this one, we call it the graph, and we have the pictorial presentation as in form of pictures. So mathematical presentation, first of all, how to measure the central tendency. We have the parameter and we have statistics. Parameter, we mean it is a descriptive measurement computed from data of population. So parameter means we are searching for or discussing something that we want to know information about it, and we have to calculate it, and this is easy to be calculated from the data of population. Like for example, taking the weight of certain group or the age or anything that can be measured. So we call the parameter. Statistic is a descriptive measurement. Also it is computed from the data but from a sample, and we have to deal statistically with this sample, and we put it in a certain either tabulation or in a graph and so on, and then we have to find the final statistical result. So first of all, of central tendency, we have to know what's the mean. The mean is arithmetic mean. It is a sum of all values of a set of observation divided by number of these observations. For example, we have numbers 5, 7, 9. The mean of these number is 7. How do we know that this is the mean? We have to calculate and we have to collect these numbers together, 5, 7, 9, and equals to 21. And we have to divide this 21 by the number of these three numbers. So we have only three numbers. We divide the 21 over the three number 3, it will be 7. So the mean here is 7 only. What are the characteristics of mean? Should be single value. It is only 7. And it is very simple to compute, and it is easy to understand, and it take in consideration all the value in the set and did not exclude any single value. We collect all the values of these numbers, and it is greatly affected by the extreme value. If the number one of these numbers was not the small one, suppose it is 100, and when we collect the numbers of 3, 7, 4, and when we add a high number like 100, so the mean will be affected by extreme value. It will be increased too. That's why we said it is greatly affected by the extreme values. So when we want to calculate the mean, we have to use certain equation, and this is the equation. The mean of population equals to the summation of x over the n, and n is capital, which means the people, they are, when we use in certain population, the people in certain population, suppose we are studying students in college or students in a school, so the whole students involved, so those involved, we call them the population. While mean of sample, we mean the mean of that sample only, so it means the summation of the total numbers of that sample and over the counted number. So this is what we call by mean of sample. Suppose we have a sample consists of the following 5 observation: 10, 54, 21, 33, 53. So the mean x with a dash, this means the mean, and here we have to collect these numbers together and multiply over the summation of the total numbers studied. The total numbers studied, we have 5 numbers only, but the summation of these numbers we have to put it here, and the total number of the figures here put down. So the summation up and the number of patient included or person included as a sample, we have to put it down. So the figure was here, the result 34.2. What do we mean by weighted mean? Suppose that 4 classes in anatomy obtain the following mean scores. We have 4 classes, class A, B, C, D, and they have mean scores on the final examination as 75, 78, 72, and 80. The question here, could you sum these 4 means together and divide by 4 to obtain an overall mean for all 4 classes? Of course not, unless the n is equal. We mean by the n, the total number of students in each class is the same. Suppose in each class we have 100 students, so yes, we can do it. We can sum these 4 means, but once the total number of students in each class is different from the other, so we cannot use this way. So what we are going to do, we have to take the weighted mean. And how we take the weighted mean? The individual value in the set are weighted by their respective frequencies, so it can be expressed as the sum of the mean of each group multiplied by its respective weight. So the n in each group divided by the sum of the weights. And here we have the equation. So the weighted mean, this is the weighted mean, equals to the summation of the number in each class multiplied by the mean degree for each class, and the result here is divided on the number of the students in all classes together. Let us take a sample, as we said previously from the previous example. Suppose that the mean of 75 is based on a number of students of 30, and the second mean is based on 40 observations, and the third mean on 25 observation, and the fourth on the 50 observation. So the total sum of scores may be obtained by multiplying each mean by its respective n. So we have the summation of n multiplied by the mean equals to the first class, class A, there is 30 students and the mean was 75, so we have to multiply and we have to collect, and it is a summation of these classes together. So we have to add 40, which is the number of the student in class B, multiply by the mean of the student in this class. And also for the third one, the total number of students was 25 and multiplied by the mean of that class. And the fourth class is the total number was 50 multiplied by the mean of this class, and the final result was 11,170. This is what we called here, this is not the weighted mean but the collect number. So we have to divide the sum of weights, the collect number of weights, and we have to divide it on the total n. What is the total n? The total students in the four classes, and this was the result: 30 in class 1, 14 in class 2, 25 in class 3, and 15 in class 4. So the total n is equals to 145. So the weighted mean will be obtained by division of the total weight over the total number of patients, and the weighted mean is 77.03. And this is a summary of the sample of the example there. The number of students in first class 30 and the mean 75, and second class number 40 and the mean 78, and the third class number 25 and the mean 72. The number in the fourth is 50 and the mean is 80. So we have to collect the mean of the weight by multiplying the number by the mean of the first class number and the mean of the second number, or multiply by the mean of the third and the number of student multiplied by the mean of that class, and it is equal to 11,170. And we have to collect then total n, which equals to the student in all four classes, and it is 147. This is wrong, here we have to add 1 here, 147, and the mean or weighted mean is equals to 77.03, as we mentioned before. Now we will talk about the median. What do you mean by median? Median, after creating ordered array, arranging data in an ascending or descending order, the median will be. How we collect the median? If it is a small number and if it is odd number, we can divide the number here, as in this example we have nine figures, and we have to find the median. The median here, we have 4 on the left, 4 numbers, and 4 on the right, and the middle one is the median. This is the middle value. But first of all, we have to arrange them in ordered manner from the least to the large one, ascending or maybe descending, but we have to arrange the numbers, and the middle one is the median. This is if the number is odd, but when the number is even number, so also we have to arrange. Here we have 12 figures, 12 numbers, and we have to arrange from the smallest one to the largest one, and here from number 2. And when we have a number that is frequently added, we have to put each one as an isolated figure, so we have to recur the number again and again as much as it is frequent. So this is only, we have only 1 number 2, we have 3 number 3, and we have 4 number 4, and we have 2 number 5, only 1 number 7, and also number 8, and we have only 1 number 12. So we have 5 numbers on the right and 5 numbers on the left, and the remaining are only 2. These 2 figures, 2 numbers, we have to collect them together and divide over 2. So the median here is 4, as 4 plus 4 divided by 2 is equal to 4. This is a simple way to collect and to find the median. Median if we have an odd or even number, but if they are small numbers. But what we are going to do if it is large number? First of all, we have to know what is the characteristic of median. Characteristic median characterized by it is a single value. It is simple, easy to compute, and easy to understand, and did not take in consideration all observation. No need to collect the numbers. We have equal numbers on the left and the right, and the middle one is the median. So no need to take all observation into consideration. Just we have to collect the same number to the left and to the right, and not affected even by extreme values. If it is high figure or low figure, it is not of that important, because we are going to take only the middle one. So how we calculate? Step in computing the median. First of all, we have to create ordered array. If it is not organized, not ordered, we have to create an ordered array first of all. And second, we have to find the position of the median, which depends on the number of observation in the set. So if it is an odd number of observation, so the position of median is n plus 1. over 2, and the median value is then specified. And if it is even number, we will have 2 position of the median, n over 2 and n over 2 plus 1. The median will be the mean of the 2 middle value. So we have an example here. This example is the following figures of age of some student. Calculate the median age. This is an question. Here we have different age for different students, and the question here, how to find the median age. First of all, we have to arrange in a proper way from the less to the high degree, from the lowest to the highest. So we have here 9 years, 10, 11, 13 after arrangement. So how we calculate the median age? As we said, the size of, here we have only 8 numbers of students. Okay, we have to collect 8 plus 1 over 2, so the size is 4.5 the item. Or here we have to know it is 4.5. What do you mean by 4.5? We mean we have 4 boxes or 4 ages. It is the age between 4 and 5. It is 4.5. So we have to see which one is the fourth one. This is number 1, number 2, number 3, number 4. Between 4 and 5, these are the 2 figures, 13 and 14. We have to calculate 13 and 14, and it is 27 multiplied by 2. It is the age, the median age for this group. And this is the way how to collect. First of all, we have to take whether it is an even number. As we said, when it is an even number, we have to add the total number over 2, half total number, and then we have to add 1, and it will be 4.5 in this example. Also, let us obtain the median of the sample consisting of 10, 54, 21, 34 and 53. So we have to array these in order, and it will be after arrangement 10, 21, 34, 53 and 54. So the number are 5 numbers. Since this is an odd number, only 5, this is an odd number, so the median will be the middle value, which is 34. Here this is wrong figure, it is 34 as seen here, not 33, it is 34. What about the position? Do we know the position? We have to calculate the numbers given. There are 5 numbers, and we have to add 1. 5 plus 1 and multiply by 2, it's equal to 3, so it is the third number. This is how to check the median. Suppose we have 100 patients. This is a big number of patients, 100 patients, and we want to know. It is arranged here in a proper way, and from the young age group to the oldest age group. These are the patients with the chronic diseases admitted to certain hospital in a certain month. So if we want to know the median, how to calculate the median for this? First of all, if it is, what do you see here? It is even number, 100. And once it is 100 or even number, how to calculate this? We have to take 2 numbers, 2 samples. N over 2, n is equal to 100, over 2 it is 50. And n over 2 plus 1, so it is 50 plus 1, it is 51. We know the position now, it is the number 50 and 51, but the exact age here for the number 50 it is 36, and for 51 it is 37. So these are the ages of, which is equals to number 50 and 51. We have to collect them and divide them. If we collect them, the result will be, as you see here, it will be 36.7. And this is the way to check for the median. Okay, 50 and 51, and we have to collect 36, 37 and divide it over 2 to check it is the median, because here we have an even number, we have to take 2 samples. Now, what do we mean by mode? Mode, the most frequently occurring value in a series of observation. Data distribution with one mode called unimodal, like this one. This is unimodal, or here, this one. This is the highest figure, the highest frequency of numbers. And sometimes it is bimodal, as this one or this one. This is bimodal too. Or it is multimodal, when there are free or frequent peak. Sometimes the data is non-modal. It is very variable, and it is used for quantitative and qualitative data estimation. So to determine the mode in any set of large number of observation, it may be mandatory to create table showing the frequency distribution of observation value, and the most frequent value will be the mode. So the same example of those patients admitted during a certain month with chronic diseases, and we have total number of 100. We have to check how frequent, which one is of the most recurrent frequency. This is the age of 1 or age of 2 or age of 3, and we have to calculate. So here it is the age of 7, it is recur in 5 times. So the most frequent number is number 7. This is the mode. What do you mean by quintile? Quintile is a value below which a certain proportion of observation occurred in ordered set of data, or it may be any of the 5 equal group into which a proportion can be divided according to the distribution of values of a particular variables. So we have to divide our observation to 5 parts, and they are equals parts. So any measurement found which one have the highest proportion, and the same as we said, we have the quintile is a value below which certain proportion of observation occurred. So suppose here we have the ages, and the highest quintile is equals to 60%. They are in this age, and another, the fourth quintile, which is less, is in the second age group, and the third quintile, which is less, in the third, and so on, and the lowest here in the fifth group. So we call the quintile. Centile, we have to series of observation is divided to 100 equal parts, and if it is in 10th percentile, we say the value below which 10 of the observation lie. And we have another common centile is the third centile, in which 30% of the observation lie below, and 97th, and also we have the 50. The 50 centile is the median percentile, and this is the example of 50 centile, and we have the 25th centile and the 27. Below the 10th centile, here it is of low value, and above the 97 it is of highest value. We have the quartiles. These are the observation in any array that divide the distribution into 4 equal parts. So we have 4 parts. Suppose we have 100 observation, and we divided this 100 to 4 parts, and equal part will have 25%. So we have the Q1, which is the least or the lower quartile, and we have the median or second quartile, we call it the Q2, and the Q3 is the third quartile or the upper quartile. What about the interquartile range? It is between the Q3 minus Q1, and it is equal to 50% of the total observation. This is regarding the quartile. And as we see here, the second quartile is the median, and we call it the 50th centile. The upper quartile is the 75th percentile, and as we say, the interquartile range is the middle 50% of all observations. So we have another exercise. A sample of 15 patients making visits to the health center travel these distances in miles. Calculate measures of central tendency. So we have 15 patients, and if they want to go to a health center, they have to pass and to have these distance to be passed, and these are in miles. So what we are going to do to know the mean, we have to calculate the amount or of miles in all these 15 patients, and it was equal to 141, and we have to divide the miles, the total miles over the total number of patients to have the mean. So it is 141 divided by 15, and the result will be, by this equation, it will be 9.4. Now regarding the median, we have to arrange the data in order, and it will be like this. First we have to find the median, and here, as the number is 15, which is an odd number, we have to add n plus 1 over 2, and it will be equals to 8, because 15 plus 1 is 16 over 2, or divided by 2, it will be 8. So this is the median, and we have to check which one is the 8th one. 1, 2, 3, 4, 5, 6, 7, 8. So this is number 11. This is the median, and this is how to calculate. What about the mode? We have to arrange. Again, we have to create a table, and we have to create the table for a frequency distribution. This is the numbers, and this is the frequency. So how many miles? The 3 miles, 5 miles. How many frequent? 2 times, 1, and so on. But 12 miles is of recurrent of 3 times. So this is the mode. As we said, definition of mode, it is the more frequent observation. So the mode will be 12 mile, since the value highest frequency. And the mean age in months of preschool is another example. In preschool children in 5 villages are represented down. Calculate the weighted mean of preschool children in these villages. So we have 5 villages, and we have number of children in each village. In the village number 1 is 44, 78, 48, 45, and 47, and the mean age in month, and it is 58 in village number 1, 45 in 2, 62 in village number 3, 60 in village number 4, and 59 in village number 5. So how we answer these questions? We have to, step 1, multiply the mean age for each village by the corresponding number of children in each village and add up the total. So we have the total number in the village number 1 multiplied by the mean, and the number of the village number 2 multiplied by the mean, and the number in village number 3 by the mean, and so on, and it is the total result 14,511. These are in months, and we have to calculate the number of children in villages, in all villages, to have the total n, and it was here 262. So by division, or by dividing the 511 and divided on the 262, these are in months, and these are the number of children in the villages as a whole, and the result is the mean. It is 55.38 months. This is, the median. And thank you.